It's real life. Nice. Mm. Okay, so hi everybody, and welcome to our second Pi Ladies meetup of the year. We had one last month, which was online. Today we are in person and streaming, but we haven't been streaming before in Hamburg for Pi Ladies event, so it's gonna work out eventually in the end. So a little bit about, let me check the mouse here. Yeah, so who are Pylades? Pylades are all over the world. It's an international mentorship group with a focus on helping more women become active participants and leaders in the Python open source community. Our mission is to promote, educate, and advance a diverse Python community through outreach, education, conferences, events, and social gatherings. And Pylades aims to provide a friendly support network for women and a bridge to the larger Python world. Anyone with an interest in Python is encouraged to participate. So you can join our Slack. We have a Slack channel, like an international Slack channel here at slackinpyladies.com. And there's a lot of channels there, but the one that for Hamburg is City Hamburg. There's also job channels for Europe and international, and also all sorts of support channels if you ever run into topic, like you have learning questions, topics, suggestions, offers, announcements, and so on. And there's a lot of events shared from all over the world that are streamed or from other chapters. Code of conduct. We expect all participants to our events and community to abide to this code of conduct, the Lady Nerds Code of Conduct. We also have the Pi Ladies Code of Conduct. So we have two. So in the Lady Nerds Code of Conduct, we follow it because we are dedicated to providing a safe, inclusive, welcoming, and harassment-free space and experience for all members and guests, regardless of gender identity and expression, sexual orientation, disability, physical appearance, socioeconomic status, body size, ethnicity, nationality, level of experience, age, or religion, or lack of. If you're experiencing anything during the meetup, please reach out during the meetup so that if there's something happening, we will just ask the person we will ask the person to stop, and if that doesn't happen, to leave the event. So let us know during the meetup so we can intervene. And the big question that always is when we hear Pi Ladies, can men attend? So short answer is yes, everyone is welcome. And think about it, that if you identify as someone well represented in open source and in tech, please be mindful of the space and privileges you have and use it to support others. So you heard a lot, the Pi Ladies is usually for women and folks that are underrepresented in tech. And some announcements. The next meetings we have on October 23rd, so we're still planning it. On November 13th, also here, we will have prompt engineering workshop with Zamina, and we already planned something from January with Pi Ladies Amsterdam. They're coming here. So, but yeah. And how to stay up to date, meetup, Slack, follow us on LinkedIn. We have a LinkedIn channel. And if you want to give a talk or your company would like to host us, please get in contact. You can contact us via Slack, we can contact us on LinkedIn or via email, as I said earlier, if you want to yourself use. So Pi Ladies is also a platform where you can use it to give a workshop, to try to give a talk. Before you apply to give at a conference, you can start here. Some announcements in Hamburg next month. There's going to be DevFest at the Sparkasse Innovation Hub. You have the link there. Please get a ticket. I think they're for free. And in December there's going to be Pi Ladies Con, which is an online event. It's going to be on all the time zones, and super international people from all over the world will be giving talks. The talks will be 15 minutes, so there's going to be a lot of talks. And today's meetup, we have a workshop that has two parts, and it's going to be data wrangling in SQL. And we have a surprise guest because tomorrow there's a conference in Hamburg, Code Talks, yes, at the cinema. And Gabor was coming anyway to give a talk. He's a developer advocate at DuckDB. So he's like, I was like, why don't you tell us what DuckDB is? We are using it, but we don't really have a lot of information on it on the slides because we don't have slides today because it's a workshop. Some other things, the workshop repository. You can type the link, you can QR the link. We can maybe put the link in Slack in the city Hamburg if you want. And actually, I will put it. Let's see. Escape.
I can put it as well.
I will put it on the chat on here. There you go. Okay. So did everybody get the link? We're coming back to the slide. So you will have to please, open the repository and so on. We're coming back to it after the presentation. And the last thing, that's not a raffle. We will change this. We will announce it at the end. That was a different raffle. Okay, so that's it. And then we start with the nice. We're going to be right back to the stream. I will have to do this thing here. Captions. Be right back. Your video is on. And
sound is? Does the sound work? Maybe we can ask the chat.
Oh, actually, someone can go and check it. The sound here, there is a bar, so it should be working.
Okay, perfect. So I'm going to time it. I don't want to ramble on, so I just want to leave space to your workshop. So hi, everyone. I'm Gabor, and indeed I'm here for the Code Talks conference, and I found this event on LinkedIn, and I'm very happy to be here and talk to you about DuckDB. So my background is that I spent a decade in academia. I did a PhD in software engineering. I worked on database problems as a postdoc, and I started a nonprofit that does benchmark development for graph database systems. And after a long winding road, I ended up at DuckDB Labs, where I work as a developer relations advocate, and I teach people how to use DuckDB, and I improve the DuckDB documentation. So what is DuckDB? In a word, DuckDB is a database system that is designed for analytics, and it's designed to do analytics on end-user devices, laptops, workstations, even phones in some occasions. The key values of DuckDB is that we designed it to be simple, free, fast, and feature-rich. What does this mean in practice? Well, I brought you a demo, and as luck would have it, I had the perfect illustration on my vase. So this is the Deutsche Bahn timetable in Osnabrück, and as you can see, basically every single train is delayed. And you will be, maybe rest assured that this is not unique to Germany. I have been living in the Netherlands for 4 years now, and people have been complaining that the railway service of the NS, the National Railway of the Netherlands, has been getting constantly worse and worse. But of course, this is highly anecdotal, so I thought, how about finding an open data set and putting this hypothesis to the test? So there is an app called Ride on the Trainen, and they have very high quality open data sets. I prepared the demo in VS Code for you. So what this demo does is that it uses a bit of preparation to just set up DuckDB. It imports the DuckDB database into the Python code. And then I'm going to start it and then explain it. We read 5 years worth of Railway data. That's 100 million records, roughly 13 gigabytes in CSV format. And DuckDB loads it in just under 10 seconds. So this is 10 million records per second, 1.3 gigabytes per second. And it has this very nice syntax that basically says, here's a CSV file, figure out what the schema is, and then load it into this SQL table. And once we have it in the table, we can actually write a SQL query. We can say we want the average delay per year. We describe it in SQL and run it in 0.1 seconds. So DuckDB takes these 100 million records and calculates the per year aggregate delay in seconds. And indeed, you can see that the hypothesis is confirmed. Since 2020, the delays have been getting worse every single year, and we are on track to be the worst year in 2024. And of course, this is not the nicest way to present this data. We may want to do some visualization. And DuckDB integrates really well with the Pandas library, so you can just take the SQL query, pipe it into a data frame called delays data frame. And once we did that, everything that works with Pandas also works with DuckDB. And we created this very simple and convincing presentation that the anecdotal stories of the railway getting worse is indeed right. To not leave you with a too sad state about Dutch railways, we can write a more complex query for the ratio of cancelled services. This uses more advanced SQL features like counting and filtering. And this one says that the percentage of cancelled trains have been getting better year by year. And again, this is scanning the entire 100 million records, and it runs in just half a second. DuckDB's interesting feature is that unlike some systems, it has a pretty complex SQL dialect. It supports everything that PostgreSQL does and a few extensions. So we can write quite convoluted queries which do some internal query, subquery. They do some aggregation, nested data, unnested data, format it, and we can answer complicated questions like what are the top 3 busiest stations in the summer month, again, in just less than 1 second. So this is just a quick taste of what DuckDB can do. And through this, I wanted to demonstrate these core features of DuckDB. So DuckDB is very simple because you just pip install it and import it. You don't have to register an account. You don't have to start a server, configure a client, or any of the difficulty with client-server systems. DuckDB is free because there is no pricing for it. There is no enterprise version of DuckDB. It's just open source. And it's very fast. We analyze this data in just a few seconds, and we did it using a convenient SQL syntax that was usually just a few lines of code for every query that we wanted to perform. More good stuff from DuckDB is its deployment model. So DuckDB is an in-process system. It's very portable, quite ergonomic, and extensible. In-process is something that's quite unique to DuckDB among the analytical database systems. In essence, the traditional wisdom in data analytics was that the analytics is very intensive computationally and memory-wise, so you need to put it on some big iron box far away, maybe in the cloud or maybe on an on-premises cluster. But then you end up with this client-server architecture where it's very difficult to communicate. And what DuckDB does is that it takes the server and it puts it into the client application. So the database system is now running in the client. And this is a truly serverless setup. So there is no server to pay for, no server to set up, nothing to configure. So where do we put the data? Well, in the demo, I run it in an in-memory mode, so you don't really need to persist the data. But if you want to persist it, you can just put it in a database file. Everything is stored in a single database file. That's very easy to just pass around then. If you have heard about SQLite, that's a system that uses a similar architecture, but SQLite is a transactional system in nature. So SQLite does short reads, short updates, and no analytics. DuckDB is in its own quadrant. If you think about database systems, it's in process like SQLite, but it's analytical like Snowflake, Vertica, Databricks, and other systems. What is the internal of DuckDB? What makes DuckDB capable of just chewing through 100 million rows in 0.1 seconds? Well, the idea is that we can play with the storage of a system to make it more tuned for transactional or analytical workloads. So traditionally, if you run something like SQLite, Postgres, or MySQL, you will use row-based storage. In row-based storage, rows of a given record are stored together on disk. And this is great if you want to insert a row or delete a row or update a row, but it's going to be quite inefficient for large amounts of data. In columnar storage, we have a per column slicing. So we store all the dates together, all the IDs, all the types, all the stations. This really lends itself to great compression because we can usually just use something like run length encoding for the dates. And it also allows us to just take whatever we are currently analyzing and do not touch any of the remaining columns. So if you do an aggregation for date and delay, then we only have to get the date column, the delay column, and we don't have to actually care about the rest. Now, this is all good and well, but this comes at a counterpart on the execution side. Traditionally, systems like Postgres and MySQL use tuple at a time execution, so they cycle through the tuples one by one, which is not very friendly towards parallelism and exploiting the CPU cache. What other systems like Pandas do is column at a time, so you take an entire column and then you just work with another column and do whatever operation is that you need to do, join, aggregation, etc. This is great, but the problem with this is that you can easily run out of memory. You can have 10 billion rows, and then suddenly it no longer fits into memory. So DuckDB uses something called vectorized execution. With vectorized execution, you take chunks of data, in this case, 2 rows at a time. And this is a kind of Goldilocks approach that takes you to the place where you get the best of both. You get parallelization, you get concurrency, and you also get, through the workload, it will not run out of memory. Here's a visualization I made of this. So you take the tables on the left, DuckDB splits them into row groups, and row groups get assigned to different threads. So thread 1 will get the first row group of 4 rows, and thread 2 will get the second 4 rows of the second row group. And then to fit into the CPU cache and to make sure that we do the processing as efficiently as possible, we only put a pair of vectors through the CPU cache every time. And luckily, modern CPUs have pretty large CPU caches. Even the L1 cache, which is the fastest one, has 32 to 128 kilobytes of data cache. Modern compilers that we use to compile DuckDB can auto-vectorize the code. So if we write the code in the correct way, the compiler will create code that uses single instruction, multiple data instructions, which allows quick processing. And by some relational operators, for example, joins need hash tables, DuckDB also has algorithms to make these run efficiently and fit into memory. DuckDB has one neat trick up its sleeve. It's very typical that people start using a database and they think we need to define indexes. We need to index whatever column we are going to query, and we need to figure out the most efficient way to index. Most typically, this is not needed with DuckDB. DuckDB is simply using something called zone maps, which is every single row group in DuckDB is having a minimum and a maximum value. And these values, as demonstrated at the bottom, allow DuckDB to be quick when filtering whatever we are querying for. For example, if we are querying for the summer month, then it will immediately just take row group 2 and cut it because June the 1st is only occurring on that row group. I said that DuckDB was designed for portability. What does this mean in practice? It means that DuckDB was written in only C++11. It has no external dependencies, and this makes DuckDB very portable. Anywhere where you have a C++11 compiler, it can be Raspberry Pi, it can be a MacBook Pro, it can be a Linux server, it will run. You can install it on all major operating systems and most major programming languages like Python, R, Julia, Node.js, Java, and so on. DuckDB is so portable that you can run it in the browser. This is an interesting thing that first looks like a gimmick, because why would you want to run a SQL engine in your browser? But what is really a good use case for this is that you can run DuckDB behind dashboards, and those dashboards will be very responsive when the user changes the filtering, the condition for sorting, or does some aggregation. It results in these very snappy 60 FPS dashboards. I said that DuckDB is ergonomic. What we mean by this is that you can get most formats and protocols in or out of DuckDB. So it supports most cloud providers, popular data formats for data lakes and data exchange. And it allows a combination of using things like the metadata stored in Parquet and the HTTPS range requests that allow you to seek into a given part of an HTTP object. So DuckDB works really well with remote data too. You can just query Parquet files that are lying around in S3 or HTTP, and it will be just as fast as it would be if it would be on the server. For the supported databases, DuckDB integrates with a bunch of databases like MySQL, Postgres, and SQLite. And it also integrates really well with Pandas, which I have just demonstrated, but also with NumPy and R's dplyr framework. The Pandas integration is really interesting because this is something that we can do this well only because we are in process. So DuckDB can just take the Pandas data frames from memory and it can read them directly. You don't even have to do anything with it. You can just have this my_df data frame and do a direct read on top of it. And then you will return the result very quickly. In fact, it's often quicker than just reading with Pandas because DuckDB has a parallel engine. And DuckDB also writes Pandas data frames. So if you want to return the result of a query as a data frame, that's perfectly fine too. We integrate with a bunch of IDEs, from dbeaver to Jupyter Notebooks and also Google Colab. And we have just released version 1.1 last week. We are kind of having nice adoption numbers in terms of GitHub stars and visits. And we have now a nice backwards compatible storage format. So this was the poster that you see was something that we actually put around all in Amsterdam during the summer. This was when 1.0 came out in early June, and now 1.1 is released just about a week ago. We have an extension mechanism. I will just quickly skip through that because it's a bit too many details. And I would like to just touch on one use case because it's a recurring question of what do you use this for after all? The main use case for DuckDB is to save money. You can do your data processing locally. You already have your laptop. That's a very powerful computer. By running your workloads on the laptop, you save on egress fees, you save on cloud costs, you save on licensing costs because it's a free piece of software, and you also save often processing time because DuckDB is more efficient. So I think the big strength in DuckDB is not that it can do something that no other systems could do before, is that it's a bit more ergonomic, easier to set up, and maybe a bit faster. And with that, I would like to give you back the floor. And let's proceed with the workshop.
Does anybody have any questions?
Okay, I have many questions.
All right.
That's a problem.
Can you repeat the question?
Yes.
My first question is, so you said use it for data processing, but then why not using, for example, pure NumPy?
Right.
Is it more than for categorical values or?
Right. So the question was, why not use simply something like NumPy for data processing? So DuckDB has a pretty rich type system. We cater for dates, strings, nested data like JSON. We also process maps, structs, unions. Most of it you can hand code in NumPy, but it gets rather difficult rather quickly. And DuckDB has a very powerful query optimizer. So sometimes we see SQL queries that just go on and on for multiple screens. And DuckDB has a join order optimizer that takes that query and then creates a join plan that is most efficient. And that saves you a lot of cycles in terms of you don't really have to figure out the optimal way of going about processing the data. You just describe it in SQL declaratively, and then it will do the number crunching in the background.
Okay, thank you.
Do you want to ask that?
Yes.
For example, this vectorized, where did I write it down? Vectorized execution. Is this something like lazy loading, when you always load what you need? And
So DuckDB makes use of lazy loading in Python, but this is used for the part where actually the execution is happening. So this is kind of orthogonal. You can use it in connection with lazy loading. You can delay the computation, but this is also a technique that's used when you do batch processing that starts immediately.
and maybe two more questions.
Yeah.
Okay.
Of course.
Is the size of my data somehow limited, what I can store? And this other question is, when you said I can have this on my laptop, but then how do I update it with incoming data also?
Okay, so the first question is, what's the limit of the dataset size?
Yeah, for example.
So DuckDB has its own binary format to store the data. And roughly, if you want to store 5 gigabytes of CSV, you need 1 gigabyte of DuckDB database size. And you're essentially limited by your hard disk space available. So I have seen DuckDB database files that go up to hundreds of gigabytes. That will be terabytes if you convert it to textual CSV size. So the limit is a few terabytes of CSV. And the other question was, how do we update it with data? So one way is, that was part of the demo, which is create table from, and then this is something that reads the CSV file and loads it into DuckDB. Here, instead of CSV, you could say Parquet, JSON, and other formats. So one way to populate the data is to use external files and then load them to DuckDB. The other formats that are supported are data sources from other databases, and you can also use traditional SQL, like you can say insert or copy or update to add more data.
But every time I want to query something, I have to load the data set, so I cannot have this in the cloud or so, or there it is updated.
Right. So you can save the DB file. So you loaded the data, and then you have your .db file that's lying on the disk. And you can always go back to that file. So it has this persistence layer. And you can also put that database file on the cloud. You can put it on S3, and then you can query it directly. So that's one neat feature. And of course, ultimately, if someone is in a big company, they would want to collaborate on a DuckDB database, at which point we are converging back to cloud data warehouses. And I'm happy to report that DuckDB has a partner company called MotherDuck, who provide the mothership for DuckDB, and they cater for this exact use case. If you want to collaborate on DuckDB, then you have database sharing, cloud storage, execution, where half the query runs on your laptop and the other half runs on the cloud, which is called hybrid query execution. And you get all the ecosystem of DuckDB with MotherDuck, but without the inconvenience of having to host your own DuckDB somewhere.
Okay.
Yep.
Okay, so wait a second. Thank you, and that's the one. And then- Okie dokie. So we're starting with the workshop, and hopefully everybody has opened it. The link, you have the link. Please open it on your desktop. And once you open it, okay. And I will check my screen. Okay, so there are there are two options to work with this, to participate in this workshop today. So it's a hands-on workshop. You will need, if you don't have a laptop, go next to someone who has a laptop. And the two options are expert mode. You can run it on your machine. We are not going to do setup assistance today. And the non-expert mode is running it in the cloud. And here you have the option to make a Git pod account. You can also just do the Git pod. If you haven't done it, you can get it for free. So if you do this, you basically go here. You can go to try for free. So you can make an account with your GitHub account, and you can copy the link to the repository here. So you have the repo link here. And configure your own repository. And you can do this. You only need standard. And you can say, okay, VS Code. You can even do this in browser, because as you saw today, it will work. So for the amount of data that we have in this data set, this will work. This is all explained also here. So if you can, like, you create a Gitpod account, you can authenticate with GitHub, create a new workspace, paste the link of this repo, choose your editor. So I'm doing this, and it's creating a little virtual machine that it is set up with Python and whatnot, just as if it were your local machine. And we have Anna-Marie here. If you get stuck with anything in the room, let us know. I will post the link to the workshop. captions. Well, so I posted the link in the chat for the event. The problem that there are two notebooks in the workshop. So one is with Fugue SQL and one is with DuckDB. And the problem is, you'll see here, our data science team needs features for predicting the customer lifetime value. Every company that has marketing will want this at some point in their lives. And the features they've asked for are 3: recency, frequency, and monetary value. And they gave you a little bit of data, and it's in a data folder. And of course, the data is in different formats. And some are CSV, some are JSONs. And just okay. So we go to the chat. And then I guess is everybody, this is still preparing. Still preparing. Has everybody managed to either prepare a Git pod? Not really. Has anybody managed to either create a Git pod or run it locally?
Yeah, I will try it.
So okay, so for the meetup, for people in the meetup, so you go to the README, which was the first page here. And this is here, you have it explained. If you're doing Git pod, you do it like this. But if you run it on your machine, you can do this. You need to install the requirements. So you have to fork the repository. You can go at the top of the repository and fork it. If you go into the here, you can fork it. You can fork it, you can clone it. And here you have the explanation, like you have to either install it locally or you can restore it on Gitpod. On Gitpod, this is taking a little bit. And actually, this seems to have worked. It's still preparing. And you go and you type the repository link. And I think here we're all on the same Wi-Fi, and that's the issue, maybe. I don't know. There he goes. So once you follow the steps in the, this is so small. Once you follow the steps in the, so even here you will have to install the, so I have Gitpod running, and here I created an account. I have a new workspace where I pasted the link of the repository. So I did this. I chose my editor. I went for the browser mode, and then you can either open VS Code from Gitpod, or if you want to run on your own VS Code, you can do that by following this. And then you will need to install the libraries. So you need to run this. So you go to your repository, and here and then I'm installing the requirements. And now if I open the first repository, which was this, now should work. Global environment. And it will install the IPy kernel and all that. No module.tv. Pop-ups. So now so I'm not using the same Python. Bin Python. Now I'm using this Python. And now it worked. Okay, so I'm using the same Python and now it works. So I did this pip install, and then it complained that it doesn't have something, and then I chose the Python that is then which Python with the shims, and then it set up the IPy kernel. Okay, so is everybody so far to loading? Like, does this work on your machine? If we also have stickers, if you want. Did you? We even had a sticker with it's working on my machine, but I think I might. So you have stickers.
I also have stickers somewhere.
Wait. Is this a duck feeding sticker?
Yes, it is. And I have t-shirts for the organizers. This is my t-shirt. But
Okay.
yes.
Okay. So does anybody? So Pelia from the audience got it. So is everybody managed to get either local run that this Jupyter notebook, the first one, is running? Is everybody soweit? Da-da-da. Nice. So Okay, so basically the workshop is like you're reading through this, you're running the first rows, cells, and then you basically have like two CSV files. You have orders, you have payments, and a JSON file, because this is life like it's at work, you know. Sometimes you get CSV, sometimes you get JSON, sometimes you get databases, and you need to read these tables. So the code is still there, you just have to run it. And now you get the customers, you read the customers, and you read the payments and the orders, and then it starts with the SQL. You will want to create, maybe we don't need the terminal anymore. We want to create the raw customer table. So, and here you see we start with the raw customer table. We have ID, first name and last name. We define as ID as an integer and primary key, and it did. And now we create the orders, and you see this SQL syntax in the cell, and we create the payments. And now we create tables, but at the moment they're empty. Ta-da. So we loaded the data, we created the tables. I think we wanted to do the other notebook first. It's fine. I think it, and then we have the orders and the payments. Wait a second. I think we have to run we wanted to do the other notebook. Let me see. SQL in Python and then creating tables. I think the other one has more explanations, but both of them are fine. They both will work. But this one is like a little bit more simplified, so it's the first version. Okay, so first one. This one is with this is Fugue? Yeah, okay. So we're going to the intro to SQL in Python. It doesn't matter if you run the other one as well, because we will run the other one as well. We do both. You will probably do both queries, but so go to, and here there's the loading the data.
Do you need to select the kernel again? Do you need to select the kernel again? Because it's not working.
That's right. Thank you. Did I select the right one? Yeah. Okay. So you're creating all the tables and then loading it, the data. And here you see you can load it with various sources. And now you have to do your first query. So we have a look at some questions. So the RFM model for customer lifetime value says you have recency, frequency, and monetary value questions. So when did the customer last purchase? That's like a recency. And then here you can run this query. There's already a join. So you're selecting user, order, customer, last name from orders, and you're joining with customers. And you have to add this yield data frame at the end to, and so this is mixing. So with Fugue, you have Fugue SQL, so you have this, you're having data frames again, but you can access them with SQL syntax. So who here likes SQL syntax more than NumPy's? There you go. So you can bring your SQL power to work and be a lot faster. Okay, so now you can write you can also then, of course, then write it as a Python function that you can use it in Fugue SQL. And then you can apply it. and you can access the new data frame, because you see here we did the yield data frame, and then you can access it. So now you have the first exercise to get what is the customer recency in days. And in case you haven't noticed, there's a solution branch, but I do recommend that you try it out first. So the both notebooks are doing the same thing, but with two different approaches. One is with Fugue SQL, and the other one is directly with DuckDB, and then you just write SQL syntax. So you can try both. If anybody has written and wants to share the solution, you can for the not from the solution branch, but your own solution, you can
Recency in days.
yeah, like if it's a date, like a date difference, and transform it into days. Like you can have it in month, you can have it in days. I could ask you in minutes. So if it's because you have two timestamps and you need, so the question was, what does customer recency in days mean? So we want this interval to be explained in as a measuring unit in days. So approximated.
I derive it from this order date.
Yeah, you have the order date there, the string, and you need to subtract.
From today or.
Well, yes. Yeah, so the point in time that we are caring about is today. Yeah, it's good. Now I need a charger. So I will put the caption. Okay, so the first exercise, I'm gonna add a new cell. Oh my God. And I'm gonna do the time difference because we like SQL, but we still don't like dates in SQL either. So we're doing it with NumPy. So we calculate it by, so we do this function that we can then call in SQL, and it creates like it applies. It's a lambda function, and it applies. It subtracts two dates, and it takes now and the date that is given as input from running the column. And then in Fugue SQL, we can just write it as recency using transforming the data frame with using this function that we just created. And we have recency in days now. You see the recency as a column appears at the end now.
I'm a bit surprised. So this is now a real pandas data frame.
Yeah, but you're doing a blend, so this is with
to me, when I check the type of DF2
Mhm.
example, it gave me back its Google pandas data frames,
Mhm.
and then I couldn't do some conversion on it.
What did you want to convert it in?
I think it was to real pandas data frame. Okay. Also I'm not familiar with this library, with this Google. So is it like a real pandas data frame?
So Fugue is giving you the option. So this is Fugue SQL is giving you the option to run SQL syntax on data frames. But it definitely, so if we look at the top, so here is the explanation. So Fugue SQL is an SQL engine. Sorry, I have to go at the top. So it's an SQL engine that can run Spark, Dask, Ray, Pandas, and it definitely changes it. I don't know exactly if your type was coming out as Fugue data frame, then it's a Fugue data frame. So I think the idea of Fugue is also like a data engineering library that you can use in data pipelines.
Yes, yes, Fugue data frame, pandas data frame,
Mhm.
pandas data frame. Okay.
So the next part is how much they spend, and here we are joining 3 tables, and we want to save that in a data frame. Let me just check that I'm still straight. So here we join the customers, and payment, so customer and payment, and saved it in a very creative way, join data. And you see, and we joined on user ID. So the user ID is the first. And now we can sum up what each user spent. Second exercise. The question is, what is the most common payment method? So here you have two options. You can do it either with a Python function or you can do it with SQL. So it's up to you. So I think we have a question from the audience regarding the Python kernel, and here I'm just going to show the environment.
In the payment table. At the very top, 9.8. So there's 3 tables. So you have payment. So here's payment.
Yes.
So I hope everybody saw their swag. There's like DuckDB swag and then PyCon conference swags from past events, and even Duskpunk. Anybody likes Duskpunk? So t-shirts and stickers. So take some. There's a code play. What? It's like code play. It is VS Code. Yes. It will be fun. Do we have any stickers?
No,
Is this your laptop or what?
my work laptop.
There are sticker removers, so you should always put stickers on your work laptop because you can always remove. That's exactly the reason. You know, like, there's like, you can buy this really good sticker remover. It's like a spray. So
I have the stickers in a collection at home, so I don't put them somewhere.
But you really need to remove them before you use it?
depends on the admin first.
if they are planning to release the
And no, here. So
what is
there's
it, Wrangling?
so what is it called? A layer or
Sticker remover.
but is it a chemical and
Spray.
okay.
It works really good. Worst case also with water. Not the stickers. Not the laptop stickers. The bad stickers, yeah. But the laptop stickers, they have the blue stickers. Okay, but yeah, but sometimes you get a laptop upgrade. And then they want when you swap the laptops because they were then giving the old laptops to the interns.
Why would one use this SQL anyways? My head is not working. It's wie sich dann leicht das Gefühl dann überstehen kann. Und das könnte man nicht mit anderen Columns. Okay.
I think whoever is done, if anybody's done with the first notebook, you can always go and do the second notebook, which is creating tables. And here we were running it earlier. And here you run directly only SQL syntax. I think we were. And can play around with that. We will probably stop streaming in a bit so that people can continue working on things. You have the solution branch, so there's the solution branch. So we are closing off the stream.
The problem with craft databases was that they all